Good morning, Cardinals. It's me, Mr. Ernst, and we're going to be talking about this assignment. I believe is part 6, I think. I think we're up to 6 now. And in this assignment, like I said, all these assignments, we are going back and reviewing everything that we've learned this year. And in this one, we are reviewing exponential equations. So this whole problem has to do with exponential equations. So let's take a look at our problem here. We're getting right into it. During a computer coding camp, Jamie and Jordan designed a game for smartphones and tablets. The partners decided to share it with 4 friends the first week. After the first week, they asked their friends to pass it on to other friends. Jamie and Jordan noticed that the number of registered players increased by 50% each week. Cool. So we have a couple of things here. The partners decided to share it with 4 friends in the first week. So during the first week. After the first week, like at the end of the first week, they asked their friends to pass it on to other friends, and it's supposed to continue to grow from there. Okay. Our first question, how many players, including Jamie and Jordan, are registered at the end of week 1? How many people are registered at the end of week 2? So we're going to set up, or I'm going to set up a little table here again. I'm going to be going through these problems to kind of help you guys out. It's been a long time since we've looked at exponential functions. So I ask that you pause this video and only use it if you find yourself very, very, very stuck. Cool? We have weeks and players. At the very start of this, the very beginning, we are starting off with 6 people. We have the 4 friends plus Jamie and Jordan, right? So we have 0 weeks. We have 6 total people. 4 friends and Jamie and Jordan. At the end of the first week, so this is including Jamie and Jordan are registered at the end of week 1. How many people are at the end of week 1? Remember, by the end of the week, it is going to increase by 50%. So what we have to look at is we have 6 players right now, and this needs to increase by 50% to the next tier. Cool? The way we're going to do this is we need to find out what 50% of 6 is so we can increase it. Best way to do this, we have 6 multiplied by 0.5. This is 50% written as a decimal, is equal to, if I plug that into a calculator, I'm going to get 3. Now, what this doesn't mean, this is not 3 players here, because we are going to grow by this amount. We are going to add 3 to the original 6. So we started with 6 people, 1 week passes, and now we've grown by 3 to give us 9. So at the end of week 1, there are 9 players. Cool? For the next one, we're looking at week 2. Instead of 6 this time, we are going to be using 9, but the same process is going to happen. We're going to multiply this by 0.5. Half of 9 is going to be 4.5, which means we need to take 9 and add 4.5, so we'll have 13.5. Now, while this is the answer that we're looking for the second week, we also want to recognize that this isn't a realistic answer because you can't have half of a player. But for this purpose, we're going to leave this as a decimal. Kind of like think of it like an estimate. We're going to have roughly between 13 and 14 people there. Think of it like that. All right, so there's our answer to number 1. This is how many players, including Jamie and Jordan, are registered at the end of week 1 and then at the end of week 2. End of week 1, end of week 2. Next question. What function shows how to calculate the number of players p after an n amount of weeks? If you remember, an exponential equation looks like this. We have y is equal to, we have a growth factor, a, raised to the power of x, that is multiplied by the y-intercept. And we are going to start with, let me shrink this. We're going to start with our a, finding out what our growth factor is. Our growth factor is always going to start off with 1. 1 is always kind of like the default, where you start off with. Then we are going to grow by 50%. So each week we're growing by 50%, so our grow is going to be 50%. So we're going to write that as a decimal, 0.50. And to find my growth factor, what's going to go here, I simply add these two together. So my growth factor comes out to be 1.5. So I can erase this and put in 1.5. Removing all this stuff. Now we can look at B. This is our y-intercept, and honestly, we've actually already done this work. We just need to find out where, when weeks is equal to 0, how many players did we have? 6. So instead of a B, and it's going to look really similar, this is now a 6. And there's our equation. Ta-da! I'm going to move this over here because we are going to end up using this a little bit later for the later problems. Leave that there. Move my colors down. All right, so there's the first two problems. Let's move on to the other problems, parts D and E. I'm sorry, C and D. Boop, boop. So C asks us to sketch a graph for the function, this function. Oh, I'm sorry, I think they had you actually using different, what was the actual variables here? Let me see, the variables were P and N. So in my equation, this is actually going to be the letter P. Yuck. There we go, P. And then this X is going to be the letter N. Cool? That's the only difference that happens there. Honestly, I'd be fine with the equation either way. A variable is a variable, but it does want you to switch those out. Okay, so now we're looking at this problem. Question C, sketch a graph of the function P for n is equal to 0 and n is equal to 15. All that means is that we want to graph a thing from 0 all the way to where it is at 15. Cool? So, because this does say sketch, we are not trying to make something incredibly accurate here. We're just trying to put together like a sketch of it. We're trying to kind of get an idea of what this looks like. We need two main numbers. We need where n is equal to 0, which we already have. And we also need where n is equal to 15. Now, I could go through this 0, 1, 2, 3, 4, 5, 6, 7, all the way down to 15, but I'm also super lazy, so I'm going to use my equation. That's what I made it for. In my equation, oops. Oh no, hold on. I messed something up here. There we go. All right, in my equation, we're going to put in, once again, I need this 15. So I'm going to be putting in 15 for that value of n. So I'll erase the n. It's going to be to the power of 15. So I am going to need a calculator to be able to do this, because that's going to be quite a bit of stuff. It's going to be off screen, so you're just going to have to trust me. I have 1.5 to the power of, whoops, I'm using the wrong calculator here. Thanks, computer. 1.5 raised to the power of 15 gives me a big old number. It is, where'd my pen go? I lost my pen. There it is. Okay, sorry. So I put this into a calculator and it gave me, this simplified out to be where'd it go? 4, 3, and I'm going to round this up to 8, so 438. So we have 438. This, when I put that into a calculator, that's what I got, and I rounded it. It was a big decimal. 438 multiplied by 6. I'm now going to put that into my calculator. So 438 multiplied by 6. Once again, rounding this off. These two numbers being multiplied gives me 2627. So it's roughly 2627. Cool? So when this is 15, we just plugged in 15, we know that we have 627. So thanks to my handy dandy equation, I have both n is equal to 0, which is right here, and I have n is equal to 15, which is right here. Notice I did not have to do the 3, 4, 5, all those other numbers. I've got my two main numbers here. So This will be roughly 0. I'm going to count out, this will be roughly, I know there's 20 lines here, so there should be 19, 18, 17, 16, 15. So this is 15 here. So 0 is going to be 0 and 6, and then 15 and 2,627. My goodness. There is roughly, there's a lot of lines here. These are 20 lines as well. So I'm going to have this count by, let me see. To see what I'm going to do for this, I'm going to do 26, roughly 2,600 divided by 20. Oops. Sorry, this is really hard to do when I've got both this up and I'm trying to do the calculator at the same time. And I, again, apologize that you can't see this. Okay. I'm going to have this roughly count up by 100s. So each one of these lines is simply going to be 100, 200, 300. So this will be 4, 500, 6, 7, 8, 9, 1,000, 1,100, 1,200, 300, 400, 1,500, which means the top will be 2,000. So I'm going to have roughly that out there. Cool? So that's counting up by hundreds on the left-hand side, and on the right-hand side we are doing, or on the x-axis, we are doing counting up by ones. Again, we are just sketching, so it doesn't need to be perfectly accurate. First one is 0 and 6. This one is basically going to look like it's right down here at 0, 0, because there's supposed to be 100 tick marks in here, so it's going to look very low down there. My second one is going to be 15 and 2,627. Very large number. So here's my 15. Come all the way up. And this is even above where this is. So it's going to be, gosh, it's going to be somewhere up here. This is a really rough sketch for them to want us to put together here. And that's okay. Now, the problem here is that I have two things from here to here. I can't really see where the curve of this is. I don't know if it's going to be really steep. I don't know if it's going to be really not steep. So to figure out what this is going to do to kind of help me out, I'm going to do this one more time and find out where 7 is. Basically, the middle marker. So in between these guys. So 0, 1, 2, 3, 4, 5, 6, 7. 7's about here. I need to figure out what 7 is. So once again, use my equation that we had from beforehand. Y is equal to 1.5 to the power of x multiplied by 6. Replace the x with 7. This is going to be 1.5 raised to the power of 7 this time, and then multiply that by 6, which gives me 102.5. And I'm going to go ahead and round that up to 103. So this comes out to be 103. So this is just barely over 100. So now we have 0 and 3, or 0 and 6, 15 and 2,627, and then finally we have 7 and 103. So again, at our roughly 7 mark, we're going to look at where roughly 103 is, which is kind of, let's see, 2, 3, 4, 5, 6, 4, 5, 6, 7. Wow, I misplaced this 7. 1, 2, 3, 4, 5, 6, 7. There we go. Pop. And now I'm going to put this at roughly the 100. So I can kind of get a much better idea of where my curve is going to be now that I have a middle mark. It starts here, starts coming towards this direction, and then it's going to have to curve really hard to be able to get up to that top number. And again, your curve does not need to be perfect. You'll notice mine looks very, very scratchy, and that is because this is just a sketch from 0 to 15. Cool? So there is C, basically using one of the first points, one of the middle points, and the ending point to get an idea of where in the world this curve is actually at. And this actually, I think, would come a little bit more like this. But again, it doesn't need to be perfect, so I like drawing curves. They're neat. They're neat little things. Anyways, Last question. How long will it take to reach 1,000 players? For this, we can use our graph to estimate. You're not going to find a perfect answer for this, but we're going to estimate 1,000 players. 1,000 players is here. So we're going to come across roughly right about here-ish, and then come straight down. And this looks like we got 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is 15, 14 at 13, it looks like. So your answer could say something like roughly 13 weeks, or between 13 and 14 weeks. Cool? And that would be the entirety of this assignment. If you guys have any questions, please reach back out to me. Again, all this stuff is a review for you guys that we've talked about earlier in the year, and this one I thought was a little more challenging, which is why I wanted to provide a video. Miss you guys. Hope you guys are doing well. Talk to you soon. Bye.